Okay, this topic, graphing linear inequalities, is something we got to pick up before we move on to graphing systems of linear inequalities. And we're going to start this by backtracking a bit and looking at an inequality such as y is less than 8. If we were to graph this on a number line, we would put an open circle above our 8, and we would shade towards negative infinity. If our inequality were changed around, and we had y is greater than 8, then the shading would move towards positive infinity. And if this were greater than or equal to, or even if it was less than or equal to, the dot above our 8 would be solid to indicate that 8 is part of the solution. So an open circle tells us that it is not part of the solution, and a closed circle tells us that it is part of the solution. Likewise, when we're looking at linear inequalities, we have solid lines and dashed lines. A solid line indicates that we're looking at greater than or equal to, or less than or equal to. A dashed line is a linear inequality that is greater than or less than. Shading above a line, above indicates that we are looking at greater than or greater than equal to. And what I mean by shading, such as this line, it means that all of my values are getting larger in relation to the y-axis. Shading below the line, less than or equal to. And in that case, I'm shading in relation to numbers are getting smaller on the y-axis. Now, if I'm shading a vertical line, it's a little bit different. A line that doesn't have a slope, or whose slope is undefined, but we'll get to that. All right, so we have examples A, B, C, and D. And we're going to graph each one of these. So for example A, I have y is less than 3x plus 4. Now my steps here, step 1, step 2. Step 1 tells me to graph the boundary line. And I've got to determine, is it solid or dashed? And then I need to determine my shading. Will I be shading above or will I be shading below? So I'm going to graph this the same way I would if it were a linear function. I plot the y-intercept, so 0, 4. And then using the slope, I find a few more points. Now if I go down and then to the left, that's going to keep my slope positive. Dashed or solid? Pretty clear this one's going to be dashed. I'm going to make it thicker, change it to dashed. And then above or below? Well, it's less than, so I need to go below.
Some drawing little heroes here, just a reminder, shade below. I'm going to get my highlighter, and I just color, because this is so much fun. Look at me go, la 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 la. I love to go.
Okay, so letter A, dashed line, and we shaded below. Letter B, dashed or solid? Solid, good. Above or below? Above. Plot the y-intercept, and hey, what do you know? The boundary line for A and B is the same. Check that out. It has the same y-intercept. It has the same slope. However, this one is going to be solid. Make that a little thicker. And then I'm going to shade above it.
Got my highlighter here. Shading, 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 so much fun.
Okay, letter C. Dashed or solid? Dashed. Above or below? Below. Okay, so I graph my boundary line. I plot the y-intercept, and then I'm going to use the slope to determine more points. Can't really go down right here. I've run out of graph, so I've got to go up. And since I have a negative slope, I'm going to go to the left. I'll do that again and find another point. This will be a dashed line. And we said that we are shading above.
And now it's time to color, color, color relaxes us and makes us happy. Yes, indeed, we love to color. Look at us go, look at us go.
Okay. All right. Letter D. X is less than -3. So this one's a little different. It's not y is less than or y is greater than. It's not that, it's x. If this were a linear function, that would be a vertical line. This is a linear inequality, and it's a vertical line. So I graph that point, -3, 0. Dashed or solid? Dashed. Above or below? Right or left? Right or left? Left. So I put in my line. I'm going to make this dashed. And let's see over here. Dashed and to the left.
Here we go, loop-de-loo. Here we go, loop-de-la. Here we go, loop-de-loo. On a Saturday night. Put my left foot in.
There we go. All right. Question of the day. Describe how to graph y is greater than -4. There's no slope there. It's just y is greater than -4. What kind of line is that? Well, that would be a horizontal line. So here's -4. There's my horizontal line. Dashed or solid? That's going to be dashed. Do I shade above or do I shade below? It's greater than, so I'm going to shade above. Yep. B, skip B, do 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 do. All right. Now I need to describe what I just did. I need to put that into words. So this is horizontal dashed line shaded above y equals -4. Which of the following are solutions to y is greater than -4? So which of the following points fall into that shaded area? I've got 0, -5. 0, -5. So that's going to be down here. Is that in the shaded area? Nope. Over 1, down 3. That is in the shaded area. So yes. Over 5, up 4. It's going to be right in there somewhere maybe. It is in the shaded area. Winner, winner, chicken dinner. And over 5, down 7. Nope. Not in the shaded area. Okay, moving on. So here we have some graphs, and we need to determine we're asked to write the inequality to represent each graph. And I have a set of steps here. So first we're going to find the slope for each graph. We also need the y-intercept. And then we have to determine if it's going to be, if the line is dashed or solid, what kind of inequality will we have if it is one or the other, and then shading above or below. All right, so the first one here, we'll start with the slope. To get from point to point right here, I go up 1 over 3. It has a negative slope, so -1/3. My y-intercept is at the point 0, 1. It's a dashed line, and it's shaded below. So dashed line, shaded below. Dashed line, shaded below. Y is equal to -1/3 x plus 1. Okay, next one. Determine the slope. Rise over run. I'm traveling 1, 2, 3, 4, 5 up. My rise is 5. My run is 1. So my slope is just plain old 5. My y-intercept occurs at 0, -2. What kind of inequality do I have? My line, my boundary line is solid, and I am above the line. So that's my inequality. Y is equal to the slope, and then the y-intercept. Next one, vertical line. So we know that this one starts with an x. The line is dashed. I don't have a y-intercept, but I have an x-intercept. My x-intercept occurs at -2, 0. And I am shading to the right of the line. So once you have these written out, make sure you eyeball it again and make sure it matches your graph, right, before you move on to the next problem. So I have a vertical line X, dashed line, shading values that are greater than that line. That line occurs at -2. Okay, next. My slope is up 1 over 1, up 1 over 1, up 1 over 1, and it's going to the left. So that's going to be a -1 slope. My slope is -1. The line crosses through the origin, so this will be a direct variation. Solid line, and I'm shaded below. Here's my slope. I don't have a y-intercept, so that's it. I'm done with that one. All right, next up, this problem came from the 2023 STAR exam. And this was one of 9 problems that was not multiple choice. So you actually had to graph it using the format, the testing format. So same as a linear function, I start with the y-intercept. So I graph the point 0, 2. Using the slope, I find more points. So up 1 and over 1 to the left, or down 1 and over 1 to the right. Solid line, shaded above. Bam. All right. One problem to go, and we are all done here. Challenge problem. A linear inequality has the points 0, 3 and -3, 1.5. As solutions, oh, that's important, on the boundary line. Okay, that's important too. Also, the point 1, 1 is not a solution. Write the inequality. Okay, so step 1, find that slope. So my slope is change in the y values divided by the change in the x values. So this is going to be 3 minus 1.5 is 1.5. And 0 minus a -3. So add the opposite is +3. So I've got 1.5 over 3, which works out to be 1 over 2, 1/2, or up 1 over 2. And those solutions are on the boundary line. That means the solutions are included. That means my line is solid. I'm going to sketch what I have so far. Another thing that you might notice is that this point right here is the y-intercept, 0, 3. So I'm going to plot that point, 0, 3. And then using my slope, up 1 over 2. I'm going to plot another point. Solid line, through those points. And which way do I shade? Well, 1.1 is not a solution. So this right here, not a solution. That means it cannot be in the shaded area. So that little clue right there tells me that I need to shade above that line, right? Now I have enough information to put my linear inequality together. So y is going to be greater than or equal to the slope plus the y-intercept. Okay.